This is example 5 working with moments. We're supposed to find x such that the system of forces has no net moment with respect to point C. What we have is a steel shape that's called a channel shape. As you see it here, it looks like the backwards capital C. The situation you actually have with the forces turns out that this is a channel shape that was a beam, and this actually represents the shear force on the beam at that particular location. And because this is what's called an open walled section, you have this flow in the flanges of this channel shape. Take the strength of materials or mechanics of materials class and you'll find out more about that detail. For us, we just want the simpler thing of note that the 250 newtons equal opposite direction and they are parallel to each other. That creates a rotational effect that in this case is clockwise. And with respect to point C, we have the 900 newtons going the other way. So we're trying to figure out what that x distance might need to be. So what we'll do is we'll sum moments about point C. Let's take clockwise as positive. We have 250 newtons. And we could take it times 90. And that distance would be, the perpendicular distance is millimeters. But notice that the other one down here is going to do exactly the same thing. So that would be times 2. So we could have actually taken 250 times the 180 millimeters and gotten the same thing and writing it out this way. Minus then 900 newtons times our distance x. We want that net moment to be 0. And then we'll solve for x. That equals 250 times 90 times 2 divided by 900. So there's newtons, that's in millimeters. And so we'll end up with x being in terms of millimeters. That's 90 over 900, so that's actually 1 over 10. So that's be 25 times 2. That would give us 50 millimeters. Well, let's just do the calculator to prove it. Times 90 times 2 divided by 900. Would not be surprised if it wasn't. But there you go. There's your 50 millimeters. It turns out that this is how you would determine what is the location of the shear center. Because notice what happens here. That the 250s cancel each other out from a sum of forces in the x direction. We have a net of 900 going now. And when we look at point C, what will turn out is that our statically equivalent section would then be such that if you could apply the 900 newtons out here, you wouldn't create this moment from the 250 times the 180. And so that's why it's called the shear center. It is a fictitious location. It only has mathematical significance to the situation.